morning, wherever you are in the world. Thank you very much for joining our webinar today. We're going to be covering decommissioning solutions for a net zero world. First, let me introduce myself. My name's Ed Kerr. I'm the global sales manager for Deep Casing Tools. So around 15 years of experience in the oil and gas business, predominantly focused on fishing, well abandonment, and slot recovery operations. Worked in the Caspian, Southeast Asia, the Middle East, and the North Sea. I'm going to take you through a little bit of a forecast of the industry outlook, and then give you some kind of hard technical information on our casing cement breaker and its recent results in its endurance testing. And then we're really eager to hear from you guys too. So we've allotted about 8 to 10 minutes at the end there to answer any questions that you might have about our casing cement breaker. So before we jump into that, I'd like to introduce my colleague Alan Glenn. Alan, if you care to introduce yourself, please.
Excellent. Thanks, Ed. Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Alan Glenn. I'm the product line manager for casing recovery systems at Deep Casing Tools. My background is predominantly fishing and P&A, both onshore and offshore. I've worked in several locations globally as well. I was taken on by Deep Casing Tools to oversee the casing cement breaker and the product line of casing recovery systems. So thank you for joining.
Thanks, Alan. Let's talk a little bit about the industry outlook right now. Where do you see the outlook on decommissioning and slot recovery as we stand today?
That's a good question, Ed. I mean, as we stand today, it's certainly a lot more positive than it was perhaps last year, obviously due to COVID and the logistics of continuing offshore operations. There's certainly a lot of projects that are beginning to happen, especially in the North Sea just now, which is only good for the industry. So yeah, I would say the outlook is a lot more positive now than it was last year.
I concur with that for sure, Alan. So here's another one for you. How do you see decommissioning fit into kind of overarching goals for net zero? We obviously see quite a lot of ESG messaging in our daily lives. Where does decommissioning fit there?
I think it fits in quite well. I mean, if you look at especially the OGA with the subject of perhaps reusing offshore assets for carbon capture, there's also various companies out there who are actually reusing topside equipment for new fields. There's been about 8 done in the industry so far. So I mean, certainly the oil industry is definitely in a prime position to look at net zero and obviously to add value to it with the engineering capabilities.
Fair. And tying that overarching strategy of goal towards net zero, where do you see our company, Deep Casing Tools, kind of enhancing the realm of decommissioning and plug and abandonment?
Well, certainly the technology that we're bringing out, certainly with the casing cement breaker, which is there to aid existing technologies and ultimately reduce cost and time to clients. And again, that is further working towards a net zero
quite right
line that we need to all look at. Quite
right, man. So let's without further ado, take things a little bit more technical. I think we've got quite an audience dialed in who really want to hear kind of the nuts and bolts of the cement breaker. So let's break away into that. Let me get a presentation on our screen. It's about 9 slides, guys, and we'll play forward here. Okay. Decommissioning solutions for a net zero world. And just for the audience, the way we're going to do this is I'm going to present it, and we're going to try a little bit of natural back and forth between Alan and I, covering some of the frequently asked questions that we receive as customer-facing folks within our organization. So I'd like to explain really some fundamentals, what a casing cement breaker is. That's what it is. It's a pipe deployed well intervention tool that's used to crack and rubbleize the cement behind the casing without the need for perforation and without permanently damaging the tool. All of the movement of the casing itself is within the elastic yield limitations of API 9 5/8 casing. So how does it work? Well, it operates by transforming surface rotation, the top drive, and combined with a fluid flow through the tool. That fluid flow is choked with a nozzle on the nose of the tool, which generates a back pressure, strokes out a set of pistons in series, which move a active roller to deform the casing. Then the rotation applies that force radially 160 degrees, 360 degrees, around the circumference of the ID of the casing, and that process is done with such force that it's able to break the cement bond on the circumference of the OD of the casing, and also rubbleize it into small particles, therefore reducing the friction required to pull the casing, or indeed open up channels and flow path for the injection of resin or conventional cement for cement squeeze operation. So it's drill pipe connections NC50 top and bottom. So it's designed for deployment with drilling rigs, but with some of the operating parameters that we've proven during recent endurance testing, with the relatively low torques, low flow rates, and back pressures, we do see this tool being capable of being deployed on hydraulic workover units, type that you see quite commonly in the North Sea and down in Southeast Asia as well.
And just a question on that. Is there, that's one of the questions that we do face, is about damaging the ID of the casing, therefore perhaps limiting if you were to run in with a spear to pull the casing to surface. Has there been any signs of that?
Really common question that we get from clients, that Alan. The short answer is no. All of the expansion work that we're doing is within the elastic limit of casing, and we're looking at anywhere from K55 right up to Q125 casing that we've modeled. Our recent endurance testings with P110 casing, absolutely no concerns with that. Also measured at various points within the ID of the casing post functioning. We expect we see no change to ID, and therefore the tools deemed suitable for recovery with existing industry casing spears, for example. So what I'll do is move on to some of the benefits of where we see it fitting into the plug and abandonment space. So certainly to increase the length of cut and pull segments, reducing the number of cut and pull BHAs being run in and out of the wellbore, therefore enabling more predictable, more efficient P&A slot recovery operations. So obviously a lot of time spent on section milling operations. Every well is different, and there's no silver bullet to P&A, but there's an extensive reliance on section milling and pilot milling operations, particularly in the North Sea, Norway, and the UK, where we hope to offer an alternative solution to turn wells which could perhaps be assigned as only solvable by section milling, to enable them to be abandoned with a cut and pull approach instead. So eliminating the time and risk, swarf generated, etc., with milling operations. We see scope for the tool to improve the wash cycle of perf wash cement operations. Great technology. We all want to leave casing in situ if we can. I think perf and wash is going to get us there, but where it's perhaps not performing as well as it could be is in the wash component of that application, particularly in wells with cement stringers, patchy cement, all the way up to heavily to full cemented applications. So scope for us to improve, perhaps enable perf and wash on more wells where previously perhaps that had been limited to wells with a relatively clean annulus, or an annulus which was capable of cleaning with conventional jetting applications or tooling only. We also see, similar to perf and wash, we see it to be able to enable injectivity for more simpler cement squeezers and resin squeezers, perhaps running a gator tool and a service packer, or a gator tool and a set of swab cups to post a casing cement breaker run, to provide a simpler option to displacing an environmental plug. Other alternatives, perhaps it could play a role in wells with SCP, sustained casing pressure, would perhaps enable a challenge for that shallow gas, for example, to be removed from its pocket and to be able to be released into the annulus to surface and then bled off, to then enable you to intervene on the well with more conventional cut and pull or perf wash cementing operations. So we're very open to alternative ideas for the technology too. We'll be doing a poll during this this webinar. So you should see, keep an eye out for it. You should see a couple of choices there about where you see the cement breaker fitting into your operations, whether it be cut and pull, perf and wash, more simpler perfect squeeze operations, or something else. Please tell us. So here's how the tool operates mechanically. So I mentioned on slide 1, we will we'll deploy the tool in whole. At the moment, it's designed for deployment standalone, but we certainly believe in the capability of combining this tool with a cut and pull BHA or a perf wash cement BHA in future. But for the time being, as we commercialize the technology, we're looking for a nice simple standalone cement breaker run. Once we're at depth, we would pump, choke back pressure through a nozzle in the nose. That would drive the static roller outwards. Then we would commence our radial operation with rotation from surface. We're quite well advanced in our commercialization of this technology. This tool has a field run. We have run this tool successfully in 2019 with Equinor on the Huldra field, successfully reducing the pull forces required to pull a segment of heavily cemented casing. So it's fantastic case history to kick things off with a generation 1 prototype of the tool. We've had a goal over the past 2 years to make generational improvements on the tool so that it can function for an extended period of time. Hence the 20-hour endurance testing, which the tool has completed, which I'm going to leave to Alan to provide a summary of. But prior to that first Huldra trial with the Generation 1 tool, we're carrying out pull force reduction testing to validate that post treatment, if you will, post pass of the cement breaker, that we're able to reduce pull forces. Yeah, and we certainly done that on every sample that we've tested. In some cases, up to 90% pull force reduction of cemented casing samples. So here we have a video of our endurance testing. You might have picked this up on LinkedIn a couple of weeks back too. Alan, I'm going to hand off to you to give us a short summary of the latest endurance testing whilst we let this video play here. Over to you, Alan.
Thanks, Ed. One of the biggest questions that was raised by potential clients for this was, obviously, how long will the tool be able to operate for? And they set as a target in which to achieve that, which was a minimum of 500 feet. Obviously, with the 20 hours running test, it certainly proved the tool's durability, which is something that we were obviously looking to prove to potential clients. Being a prototype, it's a new tool, and obviously getting a trial. Well, these were very important questions that clients had come to us. Now, we had done the testing in Lapwing, Norway. As you will see by the middle video, this is the tool operating, and it's breaking the bond of the cement and rubblizing it. This sample was about 4.5 meters long, and as you can see, the tool did exactly what it says on the tin. We were pretty impressed with this tool, and certainly Equinor were too, and have actually confirmed the tool at TRL 4 and is ready for their field trials, which we're hoping to get in the near future. So all in all, it was quite a stressful 2 weeks of testing, but Lapwing did really well in helping us. A lot of the testing was done remotely, such as this day and age just now, but we certainly achieved all the targets that we were looking to get the tool to where it is now. So we have a primary and a backup that will be ready for field trials. We're hoping in the next couple of weeks.
Fantastic, Alan. So one of the key goals here, and I'll let you speak again a little bit here, is that we wanted to have a firm set of operating parameters going into our next generation of field trials. So there's a couple of things that stand out for me, right, Alan? The operating pressure, torque, the force required to pull the tool through the casing while it's being activated. They're all quite manageable, aren't they? Certainly for a typical North Sea rig, but also for perhaps hydraulic workover unit operations too, eh?
Yeah, Ed, and that's actually a very good point, because with Generation 2, we've certainly reduced the torque and overpull on this model. And that was specifically designed over this past year. We've had a lot of inquiries, as you say, can it be run from a HWO unit that may not have the same rig capability as a rig in the North Sea with a derrick and top drive. So we've adjusted based on what client feedback we've been given, and certainly with this tool, we've now got it into a manageable situation for not only workover units that you might get on land and offshore as now, but also a big rig, a standard in the North Sea. So we're pretty happy with what we've managed to do over the past year. A lot of work, but we got there.
Bang on, Alan. I'm just going to draw the conversation back to a net zero goal, right? Here's just a slide to show you what we believe the CO2 emission savings that we could deliver from a typical project. If we can enable a cut and pull operation as opposed to a lengthy section milling or pilot milling operation, then that could result into as much as 10 days of rig time savings. So some of these numbers coming from internet sources of the daily emissions of a North Sea a semi-submersible rig. We could help to contribute to as much as 300 metric tons of CO2 emissions per project, per job. That's really a target that we could all get behind, eh, Alan?
Absolutely, Ed, and I think saving as it says, it's a typical saving of 10 days. And having been on the rig floor myself for a lot of days cutting and pulling casing, a lot of it sometimes maybe if the CBL log hasn't been accurate, it is guesswork, and you could have multiple trips in and out the hole, which again adds to obviously the metric tons of emissions produced per operation, and we do need to perhaps look at reducing that.
Come on. So final slide, guys. It's just to let you know where we're at. We've completed our endurance testing. As Alan mentioned, we have a primary and backup tool for field trials being assembled over the next couple of weeks to be ready for field trials in September. We welcome all inquiries and just let us know how and if you could be part of our adventure. I'll hand back to you for final words, Alan, just on where your hopes and goals for the next couple of months for the technology.
Thanks, Ed. Certainly, I would like to see the technology get offshored and into a well to prove its worth. We're firmly behind this technology, having experience of cutting and pulling casing myself. I've no doubt that it's definitely going to bring a benefit. And, you know, if you're out there and perhaps even you're on an existing operation just now and you have small sections that have been cut into even smaller sections and you want to try and take this tool out and see if it can aid in your operation, we are available 24 hours a day, 7 days a week, and we can mobilize these tools to you. So maybe that's something to think about as well. And if you've got an operation where you'd like to see these tools offshore, get in touch with us. We'd like to be involved in the planning stage as early as possible so we can give you our experience and advice.
Excellent, Alan. Well, I think we're on a time schedule here. So what we'll do is go forward into our Q&A section. Please feel free to drop your comments, and Alan and I will stand by to address them. Thank you very much, everyone.
Thank you.
All right, guys. Well, let's kick off into Q&A. I can see a couple of nice straightforward ones that we can start with, right, Alan, before we move into those more challenging ones about multiple casing strings. So first off, Alan, we tell the audience a little bit about plans for future sizes of the tools, both smaller and larger casing sizes.
Yeah, I mean, we've had a lot of inquiries regarding that, even with 7-inch and 5.5-inch tools. A client has actually asked us to do a feasibility study on how long it would take to develop these tools and have them for that's quite a large P&A campaign. And we also get asked about 13 3/8, which would be the next size up for looking at abandonments. So that's predominantly what we're looking at just now. We'll get this 9 5/8 tool qualified into the market, and we can easily look at perhaps building a bigger one for the 13 3/8 or smaller, as we've been asked to do by a client in Australia.
Yeah, fair. I think we have a bit of time to dig a little bit deeper into those smaller size applications for 7-inch casing and indeed 5.5-inch casing, predominantly sizes of casing that we see on land operations, whether it's Australia or the US. Perhaps not your stereotypical cut and pull or slot recovery application there. Tell us a little bit about why the client was interested in the CCB for those smaller casings.
The client came to us. They are looking at perhaps leaving the tubing in situ and looking at resin injectivity. Excuse me, slip up there. And obviously, you know, progressing with P&A, it's looking at reducing cost and carbon emissions. And if by leaving tubing in situ and not having to pull it or pull as much of it, is certainly a cost benefit to the client.
Yeah. So smaller sizes, perhaps for leaving and casing in situ for predominantly land operations, but the market to the other end, the 13 3/8, perhaps 20-inch as well, more offshore. Where's that interest coming from?
We had a client in Norway who was looking for a cement breaker for 20-inch casing. So always looking at challenging us and see what we can come up with. But that was to reuse conductors for existing wells. So they would pull everything out and then put in a dual well inside the original 30-inch conductor. That was a project, or that is a project that we're being asked to look at just now. So again, going up the way, it can go all the way to 20-inch, and we're confident we can do that. Going forward.
That leads quite well into this more challenging question that we have here about ensuring integrity of further annuli past the 9 5/8 by 13 3/8 annulus during operation. I guess that's something that we're very much going to learn at the field trial phase. It ties well into that requirement for conductor recovery as well, because if it's for a slot recovery, we need to be ensuring the integrity of the well beyond just the casing that we're working in. Let's do our best, Alan, then to try and answer Olapado's question about, because we've watched the video together. We've seen that force is transferred when the 13 3/8 is unsupported. Our test, of course, doesn't have cement behind the 13 3/8. That's going to be markedly different downhole, isn't it?
Absolutely. I mean, that 13 3/8, like you say, is going to be supported by cement or formation. But also, when we first looked at this project for the casing cement breaker, that was one of the things we have looked at. And by the design of the tool itself, obviously not wanting to plastically deform the casing, we took a little study, and we've found out, obviously, cement is a lot more brittle. So when there's forces on the 9 5/8 transist through, it's the cement that's going to give way, not pass that force through to the 13 3/8. And that's what we're confident in the tool. It is a question we do get asked a lot. You obviously want to maintain that integrity behind the 13 3/8, especially at the shoe.
Yeah, good explanation there, Alan, for sure. Let's go to another straightforward one from Parry Hillis here on what the typical operating time is per zone, and whether we're moving the tool in the hole or out of the tool hole. That's one of the things, firming up the technical specifications, which we have done from the endurance testing. Just recap on that a little bit in terms of operating speed and direction of operation.
Okay. The testing that we have done just now, the optimum RPM for the tool is around 60 RPM. That can change. That will give you about 0.6 meters a minute pulling out of hole, which is a lot of our testing has been done, including that lapwing test. So basically, when we run the tool, we would run it into depth and then kick on the pumps to around 3,500 to 4,000 psi at the tool through the rig pumps, and they're 60 RPM rotation, and we'll be pulling out the hole at the moment. We do look at further testing to see if we can get the tool to go down the way, but obviously when you start putting in string into compression, it can lead to problematic areas. So at the moment, it's pulling out of hole.
Yeah, that makes sense to me, especially for shallow applications where we might not necessarily have weight to push a tool in the hole. So here's another straightforward one for you. The casing diameter after operation in 9 5/8 test. Of course, we've covered the presentation that we're deforming the tool within its elastic limit, so it goes back to its original size, right?
Absolutely. In all testing that we've done on 9 5/8 and 9 7/8, we've taken engineering dimensions of the test samples, and all samples have returned to the original dimensions before the test. So it's not going to do that. And also the tool is restricted. We've worked out how much in millimeters you would have to manipulate casing for the cement to break, and it's nowhere near to deform it permanently.
Roger that. Next question here from Chad Ragas is, when can we expect to see the other sizes? I guess maybe a way to best explain this is that client support is a big help, of course, isn't it? As is state sponsorship from the likes of the Net Zero Technology Center. Perhaps you can help elaborate on and answering that question, maybe by talking a little bit about the sponsorship opportunity we had in Australia for the smaller sizes of tools.
Absolutely, Ed. We have been, as I had said there, we've been approached by clients to look at smaller or bigger sizes in the tool, and we're always open to meeting those challenges, especially the engineering challenges of bringing something to a smaller size. And they have offered, we can come to an agreement with regards to funding and support for it, especially in these times just now where everyone's suffering, as it were. So no, definitely we're open to sponsorship of larger and smaller tools if anyone would like to get involved in that journey, which 2 major clients have already.
Excellent. Well, I'm going to give you a bit of a breather. I'm going to pick up a question here from an anonymous attendee who would like to know what's driven Deep Casing Tools to venture into decommissioning and plug and abandonment after a decade-long history in completion and well construction. Because, of course, most of you might know Deep Casing Tools as providers of turbo runners, turbo cases, and more recently, our Mechlock drill pipe swivel. So the short answer to that one really is that it's a growth area for the industry, particularly in the North Sea, but we're seeing high growth in Southeast Asia, the Middle East, Gulf of Mexico, and indeed US land has a huge volume of wells requiring a P&A over the coming decades. So large growth area, but combining the in-house engineering team that we have, I think, is big strength that have been with us for a while now, developing and introducing simple but innovative products to the completion, well intervention, and well abandonment sphere. So that's the short answer is really the opportunity, the growth, particularly where we're headquartered as a UK-based company. I'm proud to develop and manufacture within the UK itself. It's close to a burgeoning market, and it fits in with our goals. We're titled here as the Decommissioning Solutions for a Net Zero World. We want to be a part of that. We want to be there. Responsible P&A appeals to us. Whatever we can do to reduce the carbon footprint and the carbon intensity of rig operations, then that's right at the core of Deep Casing Tools. So let's take a look at a couple of other questions. You touched on it already about whether we're looking for partners for further development. We're obviously engaged with a few in Norway, UK, Australia, but we're very open, right, Alan, for new partners.
Absolutely, and as the presentation stated there, I mean, we're looking to enhance existing technology, and that technology is either with other service partners, whether it's a fishing company who are doing the cut and pull, or it's perf, wash, and cement. So yeah, we are looking at alliances with service providers, and that shows the client that there's more of an integrated approach, which, as we know with decommissioning, it's one of the main things operators are looking for, is more integration between service companies. So we're on that boat too, and we are looking to partner up with those who have these existing technologies, and it can only benefit us both, and obviously the client at the end of the day.
I'm with you, Alan. Let's go on to one more. Actually got room for a few more. Chad, again, great questions, Chad, right? Will this tool be able to run off motors? And will it work with all fluids? That's a good one, right? Yeah,
that is a good one. That's another question that we have been touched on by clients. At the moment, we haven't done any testing on motors. It's predominantly been with top drive, power swivel, and rig pumps. We can look at that. We do have a motor in our warehouse, funnily enough, and a test jig for that application. We just haven't got around to doing it. But yes, going forward with some of the lighter intervention rigs, and that is an application we would be looking at.
Yeah, where I see that working, I guess, is the smaller sizes. Once we downsize to 7-inch, 5.5, we'll be working with work strings with minimal torque, maybe even EUE connections with low torque ratings. If we can avoid transmitting torque from surface, then that's the area, particularly for a tool working inside 5.5-inch and in more deviated wells. I guess North Sea, we think of relatively shallow, relatively vertical wells, but as we take applications deeper into the wellbore and we add deviation, there's certainly scope for mud motors. It's just selecting, I think, the right high torque, low volume or low flow rate motor would be the ideal pairing, right?
Absolutely, absolutely.
Okay, let's tick off some straightforward ones, which we might have run through the tech spec sheet quite quickly there. Could you help us recap on the operating pressure differential, the circulation flow rates involved in a typical cement breaker operation, Alan?
Yeah, sure. The operating parameters are 60 RPM. This is all what we've been testing to. 60 RPM, yeah. 3,500 PSI to 4,000 PSI operating pressure of the tool. And that gives us the optimum pressure at the tool to break the bond of the cement and manipulate the 9 5/8 casing.
Fair. Got a good question from Dave here as well about wear and how the tool could be redressed on location. I think we've spoken a little bit about how the active roller, perhaps treated like a grapple or disposable item, that's what's going to wear first, and that the tool is designed to be field redressable. I guess it goes on to rather impressive results that we really want to shout to the world about is 500 feet and 20 hours of endurance testing without much wear. So perhaps you can recap on the endurance, what the tool looked like after the endurance testing, Alan.
No, absolutely. And I can definitely say that it exceeded our expectations. We had done a lot of testing with various materials. A lot of it was trial and error. A lot of it gave positive results. There were some that gave negative, but we feel now that we've found a material that during the testing had minimal wear on the active roller. It could be run, I would definitely say, for another 5 to 1,000 feet. But the static and active rollers had zero wear. I'm confident in saying zero. That we found the right material for this application.
Excellent. Let's move for one more, and we've got time for two more. Alliances, right? We've spoken about our collaboration with operating companies in Norway, Australia, and the UK. But it's not just end users, operators that we're interested in alliances and partnerships with. Perhaps tell us a little bit more, Alan, about how we could make a model win-win for a mid-size or a large size, or indeed a small service company too.
It's a good question, Ed. I mean, at the moment in Norway, we have an alliance or partnership with Archer. They were the ones who supported the very first field trial in Norway at Huldra, and it's certainly something that, as I was saying, the more integration with service companies that we have benefits everyone. So we are open to having alliances with service companies, and I think that's the way it should definitely be continuing in the decommissioning market. So if you've got a tool, and again, it goes back to enhancing existing technology. So if you're a service provider and you have a tool that's involved in removal of casing, cut and pull, or perf and wash, we'd like to be in alliance with that too, because we can benefit your product line.
Absolutely. All right, so let's here we go. We can finish off nice straightforward one, because we have test validation on this. It's a very common client question. Can the casing cement breaker expand through a casing coupling? And I'll add to that, in uncemented and cemented applications. Alan, how would we fare?
I would say we fare very good, and we've actually done testing on 9 5/8 coupling, and we've done it several times, and at no point was the integrity of the coupling damaged in any way. So we are confident we can pass through a coupling without damaging it at all.
Excellent. And what about the tool? How does the tool fare up as it passes through?
The tool fares up very good. I mean, we don't see any increase in torque or overpull or anything like that. Obviously, if you've got, say, a buttress connection, and there's a gap, we would obviously, as with anything regarding fishing tools, we would prepare for the approaching the coupling and take it easy going through. And that's exactly what we did in all our testing, in a plain bit of 9 5/8 casing and a cemented piece of 9 5/8 casing with a coupling. We just took it easy.
Excellent. Excellent, Alan. Good answer, as always. We've got one more before we finish up at 20 to the hour. So this last one here from David Davies about, is one pass required to with the casing cement breaker, or would we have to run in and make multiple passes to ensure the cement was rubberized to the particle size of our satisfaction? Second part to his question is covering the rate at which we're making those passes, which we think we covered, but very briefly. So if you could just recap on our expectations in terms of passes and pass speed.
The video that was posted on LinkedIn, I hope everyone was able to see it, because it certainly showed the benefits and the results of the tool. That was one pass at 0.6 meters a minute, which was the optimum parameters for that. I'd like to think it would be one pass, but with downhole applications, you just never know. So I would say 1 to 2 passes just now.
Excellent. And the final part of David's question there is only pick up or reciprocate the tool across the section. I think we need some back pressure in there as well, Alan?
Yeah, and at the moment, as I said, it's just pulling out of hole. We would run the tool until we had done some more testing for pushing it downhole.
Great, great. I think we covered everybody. I just want to pull back up to Abdul Hamid's question, which we did answer generally about the future of new sizes that might need speed to expedite those. Looking at client funding, we're very much open to that. But plans for 18 5/8 and 13 3/8 casing, Alan.
Okay, the 18 5/8, I can say we are in discussions with an operator just now on that tool. They've seen the testing of the 9 5/8 and have been encouraged that we could do that. That is being looked at and discussions are ongoing for that project. 13 3/8 we get asked every time because it's obviously a popular next size up. Yeah. We're confident now that we've got this tool that is ready for field trials at TRL4 as per Equinor, that we could make it bigger to accommodate for 13 3/8. We're confident in the technology.
Excellent. Excellent. Thanks, Alan. Well, we're just about done for time, 2 minutes over. So I'll just start to wrap things up. And thanks to the audience. It was really great participation. We'd love receiving and answering all your questions. If you have any more, feel free to follow up with us on LinkedIn or email as well. And Alan and I will take care of any onwards queries you have. So without further ado, thanks for joining our webinar. Have a great evening, morning, wherever you are in the world. It's been an absolute pleasure. Thank you.
Thank you.